You're listening to Maximum Medicine Radio with host Doc Martin. Stay tuned in or call in. You won't want to miss what's happening next. How do you step into your maximum potential? How do you connect your spiritual drive with your physical path? Stick around as Doc Martin takes listeners on a journey through the seen and unseen, the accepted and the unbelievable. Get ready to meet the maximum you the world needs on Maximum Medicine Radio with Doc Martin now. Hi, everybody. I'm Doc Martin, Maximum Medicine Radio. And we're going to talk tonight with Dr. Lee No, who is a naturopath based in Toronto. And what I love about what we're going to talk about, I have to confess, I'm a little late to the game. But the first part of the show, we're going to talk about the mitochondria. And as I get older, I'm more and more interested in everything the mitochondria do. But we're also going to talk about the endocannabinoid system. And for the psychoactive effects, that's what marijuana THC interacts with, is our endocannabinoid system. But there's another half of it that does so much more. And we're going to talk about that because Dr. Lee No is really, really knowledgeable about this. And he has a company supporting these phenomenal products. So Lee, thank you so much for being here.
My pleasure. Thanks for having me.
This is so exciting. So I stumbled upon your book later than it was published. It was published or republished in 2018, your book on mitochondria. And at the time you wrote it, you were talking about it as the future of medicine. Now, I understand from an email exchange that you actually wrote that earlier than 2018.
Yeah, so so in 2014, that was I self-published an edition of that book. What's interesting is that I actually started this journey in and around 2010. That's where my interest in the mitochondria really started to develop. And it really started with a company I was working for at that time. And in Canada, this company was essentially the go-to brand for coenzyme Q10. And this brand sold products throughout the entire medical community, everything from natural health practitioners and naturopathic doctors to conventional medical doctors like yourself, and even hospitals. And in and around that time, we start to get interest from fertility clinics because there was some interesting data coming out suggesting that a subset of infertile women should or could benefit from the intake of coenzyme Q10. And there was one fertility clinic in particular that wanted me to come and do a presentation for them to help educate their doctors and nurses as to why they need to be recommending CoQ10 to their patients. And of course, talking to with an audience of medical doctors and nurses, I really needed to know my stuff. So I started to dig deep into the research, and that's where my mind kind of exploded a little bit because as I, working for this brand, I knew that coenzyme Q10 was great for cardiovascular health. I knew it was good for mitochondrial diseases, but I didn't really understand how it tied into fertility. And like I said, as I dug deeper into that, I started to realize that mitochondrial function is so important for essentially all degenerative diseases. And what fascinated me even more was that it was tied to things like longevity, cancer, things like that. So when I was coming across all these incredible resources, and there was a lot of amazing research that was done, but there was no single resource that pulled everything together. And so I thought that this is something that needs to be written and put out there. So it took me about almost 4 years, both in the research and the writing, to pull that together. And that book was launched or published in 2014. It did fairly well. Thankfully, it got picked up by a couple prominent doctors that had a pretty decent following on the web, and it did well enough that it got the attention of a traditional publisher who contacted me in around 2017 And to make a long story short, I signed the rights over to them, updated the book under a new title, and it was launched, as you said, in 2018.
And the more I learn about mitochondria, we talk about aging and telomere length and, dementia, and we talk about plaque, but then those are very superficial once we start to learn more. And mitochondria are like, seriously, we call them the powerhouses of the cell, but we're talking, these are serious badasses. I mean, mitochondria are amazing. So tell
100%, yeah.
me, give me a synopsis. I mean, even the idea that once upon a time a mitochondria was another cell absorbed by our cells and then evolved along with us, inside each of our cells. So just tell our listeners some background of these little guys.
Sure. Yeah, and this was also one of the things that really um, got my interest when I started researching the evolutionary biology perspective of the mitochondria. So, in fact, according to evolutionary biology, it's theorized that it was the creation of mitochondria that essentially gave life to Earth as we know it. So this dates, billions of years ago. Don't quote me on. I want to say like 1 point something billions of years ago,
Mm-hmm.
where Earth was basically just covered in single cell organisms or bacteria. And normally, what happens when one bacteria engulfs another bacteria, that engulfed bacteria is essentially digested and destroyed. But there just happened to be this chance occurrence where one bacteria engulfed another bacteria, and instead of digesting it, it became a symbiotic. There formed a symbiotic relationship, and over the course of several hundreds of millions of years, what ended up happening was that engulfed bacteria um, became the mitochondria, and basically it took on the role of energy production for that particular cell. And now, with that cell, with a specialized organelle to create energy, what it was able to do is divert a lot of its other resources to other aspects of the cell. And now, because the mitochondria can produce that energy, and mind you, the vast majority of the energy that our bodies produce or our cells produce come from the mitochondria. So now, with a specialized part of the cell pumping out all this energy, the cell had enough energy to then grow and become more complex and form what we call eukaryotic cells or multicellular organisms. So, like I said, according to evolutionary biology, it almost seems like this was the event that led to multicellular organisms on Earth, and to me that's incredible. And
Amazing. Mm-hmm.
yeah, it is. And even to this day, mitochondria, when you look at the way it functions, you look at its own set of DNA, things like that. It totally resembles bacteria, and again, because it comes from bacteria, it's also a lot more susceptible to certain antibiotics and things like that. So there's a lot of strong evidence to suggest that this is what we thought happened, and what we think of the mitochondria as once being an individual cell or a separate entity is in fact how things kind of progressed over the last 1 point so many billions of years.
Mm-hmm. What I love also about that is if I look at the symbolic nature of that happening, of that occurrence, and I kind of extrapolate it to and take a futuristic view, if we as humans need to evolve more complexly, with more capacities, here is something in our deep evolutionary history where unity and cooperation led to big, amazing things. So when I just want to do a little shout out to that sort of symbolic nature to remind us that, something as odd as one cell Pac-Man swallowing another, but instead of chewing it up and spitting it out, it said, okay, why don't we do something together? I think that's like double cool. I really
That
like.
I've never thought of it that way, but now that you say it, I 100% agree. That is an incredible way to kind of look at that, because now more than ever, I think we need to understand that we can move forward a lot better through cooperation
Mhm,
and working together as opposed to competing and destroying each other. So
mhm.
100%, that is an awesome way to look at, the history of the mitochondria and teaching us a lesson that is relevant to our current state of being, as well as, like you said, if we want to push forward and evolve into greater things, we're going to have to understand that cooperation and working together is the way.
Yeah, and get rid of our Neanderthal Pac-Man mentality.
Yeah.
Huh. You said CoQ10, and I'd like to talk just a little bit about that because there are many components within the pathway of the mitochondria, and it includes different chemicals, which are the nourishment or the key um, the key factors in biochemical pathways within the mitochondria. Could you talk about CoQ10 and other things in that system that produces our energy compounds?
Yeah, so CoQ10, the reason why it's so critical to the function of the mitochondria. So keep in mind, our bodies normally produce sufficient amounts of CoQ10 in our younger years, but it's thought that starting in around our 30s, our bodies just naturally start to produce less and less CoQ10, and that's one of the reasons why, as we get older, supplementation becomes more important. Now, where CoQ10 fits into the picture of the mitochondria is that the way that the mitochondria produce the energy through something called oxidative phosphorylation, or production of energy through the use of oxygen. And that happens in what we call the inner mitochondrial membrane. So the mitochondria have two sets of membranes, an outer membrane and an inner membrane. And on that inner membrane are a number of proteins, large proteins that we call complexes. And these complexes make up what we know as the electron transport chain. So many of your listeners might remember the electron transport chain from high school biology. Now, electrons are shuttled into this electron transport chain, and it's passed from one complex to the other. Now, where CoQ10 comes into play is it's what shuttles electrons from complex 1 and complex 2 over to complex 3. And then complex 3 shuttles it over to something else called cytochrome C, then on to complex 4. And this whole chain, somewhat of a molecular hot potato game of hot potato with electrons, that has to happen very smoothly for energy production to occur. And so you can see that CoQ10 accepting electrons from both complex 1 and complex 2 to shuttle it over to complex 3 has an important job. Without CoQ10, that entire chain falls apart. And like I said, as we start to produce less and less as we get older, we're going to need to replenish that coenzyme Q10 to ensure that we have enough that the electrons are kind of flowing through that chain uninhibited. Now, there are a number of other nutrients that are involved. One that's quite popular right now is magnesium. Magnesium is formed a part of what we call ATP, or ATP is the molecule that is essentially the energy currency of our cells. So magnesium is a part of ATP, but there's a whole bunch of other nutrients that come into play. Things like B3, a number of different B vitamins, even iron, zinc, copper. They're all different elements of these complexes, and these complexes can't be built properly unless we have the proper nutrition.
And then there's another one, and I'm not going to remember its long name, and I think it's abbreviated PQQ.
Right. Yeah. So PQQ stands for pyrroloquinoline quinone, and it's we only need tiny amounts of it. But what's interesting with PQQ, it's been shown to increase something called or induce something called mitochondrial biogenesis. So as you might guess from the name, mitochondrial biogenesis essentially means that we're able to create more mitochondria. And the more mitochondria, especially if they're healthy mitochondria in a cell, means the cell has more energy. And keep in mind, everything that happens in a cell, everything from the obvious, like contraction of different fibers, for example, when we contract a muscle, to things that we can't even imagine takes energy, things like the transport of ions and compounds across cell membranes. So literally everything that happens in a cell requires an input of energy. So the more mitochondria we have per cell making that energy, the better that cell functions. And then, zooming out, the more well-functioning cells we have in a tissue, that tissue or organ is able to function properly. So PQQ helps generate more mitochondria per cell, and that's what we've seen. So some of the studies have looked at things like cognitive health. Keep in mind, the brain is one of the most energy-intensive organs in the body. So the studies looked at various aspects of cognitive health, showing that we can increase the mitochondria in our neurons, in our brain cells, and that leads to a functional improvement in various cognitive measures.
So the thing, and I'm glad you brought up cognition, because the thing that grabbed me is I was reflecting as I'm getting older that I have some relatives that have gone before me who developed dementia. And, usually that's a family inherited thing. And they're in mainstream medicine, there's really not a lot they say, okay, make sure you get your rest, make sure you stay social and stimulate your brain, eat a healthy diet, get enough exercise. Well, that's kind of like, okay, well, can we drill it down? And so I went into the more natural health world and started exploring. And I'll just mention a set of products by Professional Health Products that were mitochondria, food for mitochondria, basically. And truthfully, I think I felt better. I thought I had more energy. I thought I was crisper. I did change my diet. I did, other things. But how would you, as a physician, as a naturopathic doctor, how would you suggest to somebody what they could do for improved overall health through the mitochondria?
Yeah, and what's really that so everything you're going to mention, I'm probably going to talk about how it was almost an aha moment for me, just because, like I said, everything I came across with respect to the mitochondria was so fascinating. But with respect to Alzheimer's and cognition specifically, as I mentioned, the brain is one of the most energy intensive organs in the body, and it's thought that at rest, so when our muscles aren't necessarily active, at rest, the brain consumes about 20% of the energy that our bodies produce, despite it only being maybe about 5% of our body weight. Taking up 20% of the energy that our bodies produce, you can tell that it's going to require a very high input of energy. Now, what some of the research, so just to finish that train of thought, so of course, if we can provide the brain with sufficient amounts of energy, it should work properly. Now, what is interesting, and I came across this during my research, was that in some cases, and I won't say it's in every case, but in some cases, what seems to be occurring with Alzheimer's patients is that there is insulin resistance in the brain. So the brain preferentially uses sugar or blood glucose as its fuel source, and that's because it's a very easy fuel source to burn and produce energy. However, if there's insulin resistance, so basically the brain cells are not able to pull that blood sugar into the brain cells due to insulin resistance, our brains don't have its preferential source of fuel. And for that reason, when we start to have um, a lack of fuel in the brain, not necessarily a lack of fuel in the blood, because there's lots of blood sugar, we just can't get into the brain. That's when the brain cells or the neurons start to uh, operate less efficiently and manifest as cognitive decline. Now, some of the research that I came across suggests that if we could give the brain an alternative fuel source, the brain cells could start working again. And that's where the research led to things like the ketogenic diet, because the brain cells can, as an alternative fuel source, can use ketones. Now, ketones are something that our bodies produce in the absence of blood glucose. And that's one of the reasons why, if you go through a ketogenic diet, you need to pretty much cut out all sugar and carbs for a period of time, so that our bodies kind of shift its energy production from. So basically, it's starting to burn fat to produce these ketones. So our livers do that. And then those ketones are able to go to the brain, get soaked up by the neurons, and our neurons essentially wake up. And we've seen incredible case studies where people have, advanced Alzheimer's and go on a ketogenic diet and essentially turn their mental health around just by going on a ketogenic diet. Now, again, I won't say that this is going to be the case in every situation. Of course, in any health condition, there are a number of different ways it can develop. But for a subset of individuals experiencing Alzheimer's that might have insulin resistance in the brain, going through something like a ketogenic diet would definitely be a consideration. And like I said, there are many anecdotes that suggest that this can work and work really well for certain individuals.
I just had a little technological glitch. Sorry about that.
That's okay.
Yeah, because that's the thing I also did. As a mainstream physician, I'll be the first to say I was not taught the things I'm learning these days. And as physicians in my world, we don't say to somebody, get rid of sugar and your thinking is going to be better. But it is. I'm not diabetic. I don't think I have insulin resistance otherwise, but even just cutting sugar out, I was crisper.
Right.
I mean, and so that's a real thing. But I also do think that when I took these, I take them several times a week. I mix them in my smoothie so I don't have to gag down a bunch of capsules. But I think it makes a difference and I'm just going to hope that I'm making my mitochondria happy, because I'm telling you, I have a renewed appreciation for what they do. And that was somewhere along the line, that decision by whatever cells decided to join forces. That was a big deal.
Mm-hmm. Yep.
Yeah. Let's take a quick break. And then when we come back, I want to start talking about the endocannabinoid system. And you've got some exciting things to tell us about CB2, one of the subsets. So let's just take a quick break. Hi, everybody. We're back. I'm Doc Martin with Maximum Medicine, and I'm here with Dr. Lee No. And I just got to say, what I love is a show where I learn something. And especially when I learn something in the realm of what I know that we as humans can do for ourselves to make our lives more healthy, more vibrant, higher quality. And Dr. Lee No is going to tell us now about stuff that I think is really going to rock your boat in a good way. So, Lee, take us in the basics of the endocannabinoid system.
Sure. Yeah. So the endocannabinoid system is a system that's common to all vertebrates. So any mammal that has a backbone will have an endocannabinoid system. And it's thought of as the master regulator of homeostasis or balance within the body. So its role is anytime a body system or process goes out of balance, the endocannabinoid system jumps into action to start a cascade of reactions that will help lead to a rebalancing of that out of balance system. And essentially how it does that is through the activation of a number of different receptors. So the endocannabinoid system there are a number of different components. First, you could think of as the what we call endocannabinoids, or they're cannabinoid compounds that our bodies produce, hence the name endocannabinoids. Now, these endocannabinoids will bind to and activate receptors, what we call cannabinoid receptors. And there are a number of different ones. The two main ones that we talk about are CB1 receptors and CB2 receptors. Now, CB1 receptors are predominantly found in the brain and the spinal cord, what we know as the central nervous system. We do find smaller amounts of it in the periphery. But CB2 receptors, on the other hand, we find mainly in the periphery and on immune system cells. What's really interesting, though, is that historically, we thought that CB2 receptors are only in the periphery and we don't find them in the brain. But the newer research actually shows that we do have a significant number of CB2 receptors in the brain, and we have more CB2 receptors under certain circumstances, which I can talk to in a bit. Now, what happens with the endocannabinoid system is that like I said, when things go out of balance, these endocannabinoids are recruited to activate these cannabinoid receptors, and will activate them to bring about a balancing of the body. Now, because these two receptors, they do have slightly different functions. And when we talk, and you mentioned cannabis and marijuana earlier, one of the things that we know is with CB1 receptors being predominantly found in the central nervous system, when we activate CB1 receptors, that's where we see the intoxication or the quote unquote high associated with cannabis use. CB2 receptors, on the other hand, we don't get that impact. So we get a lot of the health benefits related to the rebalancing and the bringing about homeostasis within the cells, but we don't get that intoxication. So that is essentially where we want to really focus on when we try to kind of rebalance what might be out of balance in the body.
So I have a lot of patients who get CBD oil and gummies for chronic pain. Mm-hmm. Where is that? Is that activating both receptors or just one? Or
yeah, that's a great question, and there's a bit of a misconception that CBD actually activates cannabinoid receptors, and despite it being considered a cannabinoid, and despite it coming from cannabis, it actually doesn't activate any cannabinoid receptor. So it does have benefits to the endocannabinoid system, but seems to have somewhat indirect benefits. So going back to our endocannabinoids, so endocannabinoids are metabolized by a number of different enzymes. And so once the cannabinoid is finished doing its job, it has to be broken down. And what CBD seems to do is inhibit those enzymes so that our own endocannabinoids can last a little bit longer. There are other things like what we call fatty acid binding protein. So keep in mind, cannabinoids are typically based on, our endocannabinoids are based on fatty acids. And so they're escorted out of the cells and for metabolism and elimination by fatty acid binding protein. And what CBD seems to do is bind these proteins so that it can't usher our endocannabinoids out of the body. So there, like I said, there are indirect benefits to taking CBD, but it seems to be more to support the role of our own endocannabinoids doing their job if there is some sort of dysfunction there, as opposed to direct activation of cannabinoid receptors. Now, this is why I also think that when you look at the best CBD products, they're what we call full spectrum CBD extracts or full spectrum hemp extracts, and that's because what that means is that there is some THC. Now, THC is a compound that we know as the one that causes the high associated with cannabis, and that's because THC will bind to and activate those CB1 receptors. What's interesting, however, is THC is also the compound that binds to CB2 receptors. So THC is the one that's actually binding to the cannabinoid receptors and bringing about most of the health benefits. But because it's binding to and activating CB1 receptors, that's where the intoxication comes from. So if anyone is looking to use CBD, the recommendation is always to use a full spectrum extract, because that's where you're going to get the actual activation of the cannabinoid receptors. I also want to kind of maybe just talk about something else called beta-caryophyllene, because
yeah, that's where I was going next.
Yeah. So cannabis. So there are the cannabinoids, but in cannabis there is another large class of compounds called terpenes. Now, terpenes we find in all sorts of different plants, and terpenes are considered the active compounds in essential oils. Now, terpenes are quite abundant in cannabis. Anyone that's had experience or been around cannabis, it gives off a very strong smell, and what you're smelling there are the terpenes. And one of the main terpenes in cannabis is one called beta-caryophyllene, or BCP for short. And beta-caryophyllene is a potent activator of CB2 receptors. So in addition to THC, when you use cannabis, and if you're using a full spectrum extract, you're actually getting a lot of CB2 receptor activation through beta-caryophyllene as well. So like I said, for anyone that's looking to use CBD, I would highly recommend that you look into a full spectrum extract where you're going to actually get cannabinoid receptor activation. Without a full spectrum extract, just CBD, you're not going to get those cannabinoid receptors activated. And that's one of the reasons why, if you looking at some of the studies coming out on CBD, and this is coming straight from research from pain clinics in Toronto studying the effectiveness of CBD, they're suggesting CBD success rate for pain is in the range of 33%. So only 1 out of 3 people that use CBD will get its benefit. Keep in mind they're using CBD isolates or pure CBD, so you're not getting the cannabinoid receptor activation, and that's one of the reasons why I think the success rate is often quite low with CBD.
So just to simplify it, if you want to get high, you want the stuff that hits the CB1.
That's right, yeah.
But if you want all of these other amazing full body benefits, we want CB2, because that's where we have beta-caryophyllene.
That's right. And
Mhm.
Go ahead.
So I want to talk more, because when I read up on beta-caryophyllene, I was like, give me some of that. That chemical is amazing.
Yeah,
so tell us about that. Yeah, tell me what you were going to say, and then tell us about what it does.
Well, I almost question, and because beta-caryophyllene, we look at the research, and I think anyone that looks at the research behind beta-caryophyllene will be blown away. It's such an incredible molecule, and I predict, and who knows how long it's going to be, but I predict at some point it's going to be the next curcumin or ashwagandha, or one of these other compounds that everyone's talking about. I actually question whether it's actually beta-caryophyllene in cannabis that gives it such a medicinal quality that people attribute to things like THC or to CBD, when in fact it's actually beta-caryophyllene. Now, beta-caryophyllene doesn't just come from cannabis. We find it in cloves, rosemary,
Black
and in
pepper.
black pepper.
Mhm.
It's in a number of different herbs and spices. So that's a great thing with beta-caryophyllene is you don't have to resort to cannabis to get a source of beta-caryophyllene. It's in many other plants. And beta-caryophyllene is unique in that it's a what we call a selective CB2 agonist. So for your listeners that might not know what an agonist is, it's a compound that activates a receptor on a cell and brings about an effect. Now, when we say selective CB2 agonist, that means it's selective for particular receptors. So unlike THC, which we would consider a non-selective CB2 agonist because it also activates CB1 receptors, beta-caryophyllene is a selective CB2 agonist, meaning that it only activates CB2 receptors without activating CB1. So you get all those medicinal effects associated with CB2 receptor activation and the anti-inflammatory effects, but you don't get that intoxicating effect. The other thing that's unique with beta-caryophyllene is that there are it's what we call a full agonist. So a full agonist is when it binds to that receptor, the effect is the full effect. Now, there are a number of other compounds in nature, including cannabis, that are seen that are called partial agonists. So, for example, THC, like I said, does bind to the CB2 receptors, but it's considered a CB2 partial agonist. So what that means is that even though THC will bind to CB2 receptors and bring about some benefits, that effect is a partial effect. Similarly, there are a number of other compounds in nature that also bind to CB2 receptors, but they're also considered partial agonists. So another example is echinacea acrylamides. And one of the things that I think a lot of people don't even realize is that echinacea works to benefit the immune system through CB2 receptors. Now, echinacea acrylamides will bind to CB2 receptors, but they are also considered partial agonists. So once they bind to the receptors, the signal it sends is a partial signal, or the effect is only partial. Whereas beta-caryophyllene, being a full agonist, you get the maximum effect when you bind to and activate those CB2 receptors. So beta-caryophyllene is a really interesting natural compound that, like I said, is completely underrated at this time. It's flying under the radar for a lot of people, but everyone I talk to that has looked at the research gets super excited because there's so much incredible promise with beta-caryophyllene, and that's what we base my company's products on. And when you look at the reviews and the testimonials that we get, it really corroborates a lot of the research that's been done, showing a lot of these different health benefits.
So I want to expand on that, but I was just thinking of something. I've read a lot, and just a thought about something I didn't know, and Ness might explain it. When you want to take echinacea for an immune boost to help you fight a cold or something, you don't want to take it every day for a long time. And maybe that's because it's a partial agonist. Maybe, I'm just turning on my science brain. But echinacea works best if you just hit it in pulse at the time you need it and then don't take it. But anyway, that's just an aside. Let's go to beta-caryophyllene because the benefits that it has are multi-system. So can you just take us, sleep and mood and pain and metabolic homeostasis and
Sure. Yeah. So our products, we branded, the brand name is CB2. So of course we call it CB2 based on beta-caryophyllene because it activates CB2 receptors, and that's the main mechanism that we're targeting. But essentially, the main reasons why people will use our products or beta-caryophyllene products are pain, sleep issues, and anxiety. And when it comes to pain, I can kind of talk about them separately. So when it comes to pain, what ends up happening is that our bodies, so for example, if there's an injury, our bodies produce pain signals that result in what we call an upregulation of the expression of CB2 receptors. So basically, this involves, a complex train of reactions that involve transcription factors and things like that. But basically, what we're trying to do, or the body's trying to do, is in that area of pain and inflammation, those cells will create more CB2 receptors. And so it's essentially putting, flags on the house, or the cells, to kind of alert the body. This is where we need the help. So when we look at things like our own endocannabinoids or exogenous sources like beta-caryophyllene, those compounds will circulate in our body until it finds, that a higher density of those CB2 receptors. So if I, for example, sprained my wrist, my body would increase the production of CB2 receptors in the area of my wrist. When I use a product like ours, that beta-caryophyllene is going to get into the body, circulate until it finds those CB2 receptors in the wrist. And once it binds to those CB2 receptors, it's going to create a signal that results in an anti-inflammatory effect and a reduction in pain. Now, for someone else, for example, some of the studies have shown that when it comes to anxiety can be a result of brain inflammation. So some of the studies have shown both when we have brain inflammation, we respond by developing anxious tendencies. But at the same time, if we can reduce that inflammation in the brain, we can actually reduce our anxiety. And that's exactly, so when going back to what I was saying earlier, historically, we thought that the brain didn't have a lot of CB2 receptors, but now we know that it does. And as I mentioned, it can be upregulated. So when there's inflammation in the brain, our brain cells actually upregulate the expression of CB2 receptors. So things like beta-caryophyllene can then go and activate them, bring down the inflammation, and that helps. Again, at least within a subset of cases of anxiety where it's related to brain inflammation, can actually really tame that anxiety. But going back
So
to
I
your
want to just sort of, you said earlier, tell me if I'm thinking correctly, that it's really good for establishing an equilibrium, resetting. And so that kind of makes sense. If there's an injury or something going on, when the receptors, like all the flags go up, here's the danger zone, here's the help. Where if you don't have that going on, the CB2 agonist, the beta-caryophyllene, won't spend a lot of time there.
That's right. Yeah,
So it's going to go where it's needed. So
that's
that
right.
makes it a very personalized, in other words, for you, it might go somewhere different than for me.
100%. I often talk about beta-caryophyllene as an exemplary model of personalized nutrition. And the thing is that usually when we talk about personalized nutrition, it involves a number of different tests and procedures to figure out what nutrient or compound or drug is better for one person based on the genetic makeup versus another. But in the scenario of beta-caryophyllene and the endocannabinoid system, and more specifically CB2 receptors, what we see is that it's the body that dictates to these compounds where it needs help. So going back to your point, it really becomes, a personalized experience where, for example, if I were to sprain my wrist, that's where I'm going to get the benefit. But for someone else that has brain inflammation, whether it's resulting in brain fog or anxiety, they're going to get the benefit to their brain. Whereas there's actually a lot of research with respect to blood glucose and metabolic aspects of health. So in those situations, those individuals will have upregulated CB2 receptors in the pancreas to improve insulin secretion. They might have also upregulated CB2 receptors in the target of the muscles, for example, where they now have better insulin sensitivity. So every individual will experience the benefits differently, and it's based on what's best for their body and dictated by their own body.
I love that. And you also have seen the research and then have been able to apply your product to animal health. Tell us a little bit about that.
Yeah, so as I mentioned, all vertebrates have an endocannabinoid system. Uh, so one of the things we actually started out as a human nutrition or human supplement brand, but one of the things that we started to realize is that there are so many individuals asking if they could use our products for dogs. So we recognize that there's a need for that in the market. So we ended up launching our Dog Ease line, and basically, it's the same products based on beta caryophyllene, labeled for dogs. And what we're seeing is that since we launched it, the demand for our Dog Ease line has grown exponentially, and now it's considered now it's our top seller. Funny enough, we like I said, we started out as a human brand, but our dog products are now our top sellers. But just as humans, it works in the same way in dogs. The beta caryophyllene will get into their body and find the CB2 receptors and will benefit the dogs where that particular dog's body is requesting help.
I just want to share with the listeners that Dr. Lee and I were talking about. I have a 6-month-old puppy who kind of got a little broadsided by the bigger torpedo of a dog, my other pet, and hurt his neck and shoulder, and that I've been struggling for a couple weeks trying to get that. So I'm looking forward to trying this product for my puppy. So I'm excited about that.
Yeah.
But Lee, I want to make sure, so if you would just tell us, I want to make sure we have enough time. We only have maybe about 5 minutes left. I want to make sure that the listeners know what your company is, how they can reach it. So if you'd share the website and anything else you think is important.
Sure. Yeah. Our website is, well, the brand, I actually never mentioned it earlier. Our brand is Cananda, and the sub lines of brand of beta caryophyllene products is our CB2 products. So I wore my shirt here because Cananda is such a difficult name to spell, but it's CANNANDA.com. So you can purchase our products directly from us. We're also sold throughout hundreds of different retailers across Canada, not so much in the US, but in Canada, we're very well distributed. We also sell our products through a number of different retail and distributors in Australia, the UK, throughout the EU, and even South Korea. So we're fairly well distributed. Now, you can purchase directly from us in North America. And you can also follow us on social media, which is Cananda Crew. And this is where we also put out a lot of different educational pieces. So for anyone that is new to beta caryophyllene and trying to understand what our products are about and whether or not it's something that would be useful for them, definitely follow us on social media. And like I said, we're always putting out almost daily. I wouldn't say every day, but almost daily, we're putting out new information for our audience.
Perfect. So I just want to summarize, and you interrupt and correct me if I'm wrong, but beta caryophyllene has benefit for your immune system as well. And it
Does,
has
yes.
benefit for helping to reduce the decline in neurodegenerative conditions. And that would be dementia, Parkinson's, things like that. So the benefits are very wide and, as you said, helping our organism restore its equilibrium.
That's right. And you know what? When you think of that, think of the fact that every single cell and every tissue and organ in the body contains CB2 receptors, it makes sense that every part of the body can benefit from something like beta caryophyllene. And when you look at the research being done on different systems and organs in the body and different health conditions, It really is wide ranging. So as I mentioned, most people will be using our products for things like pain, sleep issues, and anxiety. But it's wide ranging, everything from all sorts of different neurodegenerative conditions to autoimmune conditions to neurological conditions. As I mentioned, diabetes and metabolic syndrome. The list literally goes on. What's
Wow.
really interesting is there does seem to be some early research to show that beta caryophyllene actually benefits the mitochondrial function as well. So there is some early studies to suggest that beta caryophyllene and the mitochondria kind of dovetail together to benefit the health. So I'm really excited about that because those are two passions of mine kind of coming together. We'll see how it ends up.
So maybe we were prescient in having a show where we put the two together in the same show.
Yeah, exactly.
How about that? That's good. Well, I look forward to learning more. I'm excited about this, and I'm also eager to try it. So that's great. So everybody, Dr. Lee No, he has his company, Kananda.org. And remember to make sure that that's .com, excuse
Yes.
me,
Yeah.
that's CB2. And the science we've been talking about is very exciting. But Dr. Lee, thank you so much for coming on and talking. And I'm really excited to see how this future unfolds.
Well, thank you again for having me. This was great.
All right. Good night, everybody.
Good night.
You've been listening to Maximum Medicine Radio with Doc Martin. Tune in next time while the doc talks health, spirituality, and the impact your beliefs have on every part of who you are, body and soul. Doc Martin unpacks the challenges we face as human beings and teaches callers to open the door between the scientific and the mystical. To learn more about Doc Martin and Maximum Medicine, visit www.sharonmartinmd.com.